So hello everyone, this will be our first video on basic counting. This comes under discrete mathematics. We'll start with our first question. An office building contains 27 floors. Given that there is a building with 27 floors and we have 37 offices on each floor. That means the total number of offices, this will be a simple product that will be 27 into 34. 1024 minus 25, that is a square plus b square, 999 if I'm not wrong. Next question. A particular brand of t-shirt comes in 12 colors, has a male version and a female version, and comes in three sizes for each sex. How many type of t-shirts can be made? So, for example, if you have done the combination, permutations and combinations. So first, for identifying each different kind of t-shirt, we have first, that is, first trace of sex. Is it a male or a female one? Then size, and then color. So we have to check all the combinations to segregate them all. So there are two, that is male and female, and comes in three different sizes for each, 2 into 3 and 12 color each. In case it would be like two sizes for male and three sizes for female, then we will be separating those cases and we will be adding them. I hope we can see those kind of questions in the upcoming segments. The product will be here 72. So answer will be 72 different types of t-shirts will be there. How many bit strings of length 5 do not have consecutive ones and do not have consecutive zeros? Uh, Instead of going for a longer way, we will approach with a very simple method. That is, since we have to fill 5 individual places, the first place, when we have entered nothing, we have two options, either fill it with 0 or with 1. So whatever you choose, if you choose 0, you can't choose 1. I mean, if you have already chosen 0, you can't choose 0 because then you will be violating the condition. That means it should not have two consecutive zeros. So you have one choice here. Then the next one will also have one choice. Because if you chose a 0 here and 1 here, because you had only one choice, then this one will only leave one choice to the next one that can have only 0, and so on. All will have one choice. So in total, there will be two choices. 2 is the answer, and to be precise, the answers are these two. These two cases. Moving on to the fourth question. How many bit strings of length 5 do not have three consecutive ones and do not have three consecutive zeros? To approach this question, we will assume, okay, to approach this question, we will take total cases and subtract the cases where there are three consecutive ones or zeros. So total cases, we all know 2 to the power 5 will be there, that is 32 total cases. Now for the cases where we want to find that is three consecutive ones, so we will consider one block with three similar entities like either 0 or 1. And okay, no other block. It's 5 bit, 1 bit here, 1 bit here. So this has two options. Either it will all be filled with 0 or all will be filled with 1. Because we have to find the cases where three consecutive zeros or ones are not coming or are coming. Here we can have two options. There is no condition that the 4 one, like three consecutive fours, because if we have 0 here, then also this is also a pair. We can't ignore that case. So we'll give two options here as well. Here, these are two options here, two options here, and in total we will have eight cases which we have to neglect. The answer will be 32 minus 8 cases. If you have doubts, ask in the comment section. That will be 24. There are four major auto routes from Boston to Detroit and six from Detroit to Los Angeles. How many auto routes are there from Boston to Los Angeles via Detroit? For this question, just like the first one, not the first one, second one, there are, mm, okay, let's make a diagram first. This is Boston, and these are some stops in Detroit. There are four routes, four or six. Okay, four. There are four different routes in Boston itself. Then from there, each one has option to go to six individual better diagram. They can pursue six different routes. So this one can be attached to all, or this one can be attached to all, and similarly, of every entity of the four will have option to go to all the six. So we have in total four into six paths. Answer is 24. How many initial different three-letter? We are on the sixth question right now. How many different three-letter initials can people have? So since we are talking about initials and three-letter initials, so there is no restriction that the letter can repeat or not. Because if we have name Aditya Ahuja, the initials will be AA. We have no restrictions like that. It's not mentioned in the question as well. So we have initials. And since initials will be in alphabets only, 26 options here, 26 options here, 26 options here, and we multiply them all. This will be 26Q, whatever it is. Moving on to the next question. Question number 7. How many three-letter? This time with the condition is specified that we don't have to repeat. So the first place will have 26 options, just like the previous one. But the next one will have one less option that is already used in the first place. So the answer this time will be 650, I guess. Product of all these three. Moving on to the eighth question. How many different three-letter initials are there that begin with A? Now this is much of a simpler question. This place is now fixed. We don't have to care about it. Wait, this is meant to be here. Okay. A. Now 26 options here, 26 options here. No condition specified that we can repeat or not. So I'll take it as 26 square only, that is 676. I guess this was not 654 here. 26 into that is 625 minus 624 into 25, whatever it is. Ignoring. I guess 390,000. Ninth question. Okay, let's move on to the next page for this. Ninth question. How many bit strings of length 10 both begin and end with 1? So we have a length of 10, 5 here. This place is fixed with 1, this place is fixed with 1. We have 8 options now. Each of them has no limitations like you can repeat or not. So each one of them has 2 options. So total 2 to the power 8 options. That will be 200. 56 ways. Moving on to the 10th question. How many bit strings are there? How many bit strings are there for Moving on to the 10th question. How many bit strings are there of length 6 or less? So for the any bit string, for example, let's start from 2 itself. We have two options here. Answer will be 2. The string of length 2, we have two options. That is 2 to 2, 4. 3 places. That will be it. And so on. If we have n places, n times, that will be 2 to the power n. But we have to sum them up for this case. We have up to 6. 2 to the power 6 plus 2 to the power 5 plus 2 to the power 4 plus 2 to the power 3 plus 2 to the power 2 plus 2 to the power 1 is equal to. Either you can solve them, or if you are aware of this, you can simply do 2 to the power next number, that is 7 minus 2. Because 2 to the power 0 is not included, so we have to reduce one extra. That means 200, I mean not 200, 126 places. How many bit strings are there of lowercase? How many strings are there of lowercase letters of length 4 or less? A similar type of question. 26, since only lower cases are concerned, so we won't go to 52. So 26 here, 26 here. A similar approach, just like the previous one, and 26 to the power. What is the maximum length? 4. Okay. 26 to the power 4 plus 26 to the power 3 plus 26 to the power 2 plus 26 to the power 1. We can add them up and the question will be solved. Another question. How many license plates can be made using either two letters followed by okay, two letters, alphabets, alpha, beta, okay, alphabets, and four numbers, or two numbers and four alphabets. Now, if first two are alphabets, we have 26 options here, 26 options here, and each of them having 10 options, 0 to 9. So that will be 10 into 10 into 10 into 10. Since all of them in this part, upper part is and, like, so we will be using product. And since we are using or, so we will be adding this case. These cases are 26 square into 10 to the power 4. That is equal to 676,000,000, 6.76 million. And this one will be 10 into 10 into 26 to the power 4 now. Whatever it is, we'll be adding them some crazy value. 676,000,000 plus whatever. Okay, I'll calculate once. 676 into 676. That is 4596. 7600. Adding them up, that will be 00674 from 52 million. big number. Cases are there. That is the answer. How many strings of length 8 are there? Contains no vowels. No vowels, that means letters can be repeated. Each of them will have 21 options, that is 26 minus 5, in length 8, 21, 21, and so on, that is 21 to the power 8. Is the answer for the first part. Second part, contains no vowels if the letters cannot be repeated. Same situation. First one will have 21 options, then 20th, and so on. It will go decreasing. 17, 16, 15, 14. Or you can write if you want to write in the form of permutations. It can be written as 21p 8. Yeah, 8. This that starts with a vowel, and if letter can be repeated, starts with a vowel. So one place is having one of the five vowels, and rest seven are free. You can use anything, 26 options each. So on. Answer will be 5 into 26 to the power 7. Option 4, I mean, part 4, that starts with a vowel if letters cannot be repeated. Starts with a vowel and letters cannot be repeated. That is 26 or not 26. You have only 25 options. Letters can't be repeated now. 24, 23, so on. That will be 5 into 25p7. Moving on to the 14th question, we have to calculate 6p3. That will be 6. The formula for permutations, NPR is equals to n factorial upon n minus r factorial. And for NCR, n factorial upon n minus r factorial into r factorial. 6p3 will be 6 into 5 into 4 into 3 factorial upon 3 factorial into 3 into 2. That is 3 factorial again. Write one as well if you want. 3 factorial reduced, that will be 20. Next part, 5c1. Okay, that's combination. I'll do just one. If you want help, you can put in the comments. 5c1 will be 5 into 4 into 3 into 2 into 1 upon 5 minus 1, that is 4 factorial, into 1 factorial. Cancelling out the entire thing. 5 is the answer. One other another of combination, that is 5c3. 5 into 4 into 3 into 2 to 1 upon 5 into 4, or 5 into 4, and minus r. That is 2 factorial into 3 factorial. That is 10. If you have any doubts in the any of the parts, you can put it in the comments. It will be there tonight. So I'll be responding very quickly. How many bit, coming to the 15th question, how many bit length strings of length 0 contain? At least four ones. That's 0. Okay, it's not 0. Coming to the 15th question, how many bit strings of length that must be 10? So 10 places. Has exactly four ones. So if we have four ones, that means other bits will be 0. So total, if you know how we solve the questions of repetitions, for example, we have Maggie. We want to see total permutations of this word. We are not sure if we use 5 factorial simply, we don't know the positions where this G will be ahead or this G will be ahead. So for that case, we divide it by 2 because half the time this will be ahead, half the time this will be ahead. So for the formula for that is n factorial upon with the repetitions. That means 2 factorial because there are 2 G's. For example, if this was the case, so 2 I's with 3 M's, everything will be in the denominator. And 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 factorial upon this. But since this is not the case, we'll come back to our question. Total we have 10 places, 10 factorial, and we will divide it by 4 factorial, 6 factorial. We will calculate the answer. I guess that is 10 into 9 into 8 into 7. 6 factorial I have cut out because of this part. Now this will be 4 into 3 into 2 into 1. So 4 into 2, 8 deducted. This will be 3. That is 21 and 210. Answer exactly 4. At least 4. So for at least 4, we will take 4, 5, 6, 7, 8, 9, and 10. We will take individual value and add them up to, like, let me do half part of it. I don't want to waste the time. At least. So 4 are there. This will be 210 plus 10 factorial upon 5 factorial, 5 factorial. Because 5 zeros, 5 ones. That must be something you can solve. Plus 10 factorial upon 6 factorial, 5, 4 factorial. Plus 10 factorial upon 10 factorial, 3 factorial. Plus 10 factorial upon, and so on up to 10 factorial upon 10 factorial, 0 factorial. 0 factorial is 1. So 10 factorial upon 10 factorial, that is, this term will be 1. Now, same for the at most. At most, we will take from 0, 1, 2, 3, and 4. And we will be done with it. A group of a group contains n men and n women. How many ways there are to arrange these people in a row if men and women are alternate? Since we are asking them to sit in the alternate position, first position will be, mm, okay, let me do a simplification for you. Now we will divide this problem into two parts, or the first position, it has 20 options. I mean, 2n options. Okay. And if 2n, because n men and women, but whatever the position, it will be taken by the first. If it is a man, then the next one has to be a woman. So then we will have only n options. Then we will add n minus first position, this position, then The equation will have n minus 1 because it will be from the set. So avoid this confusion. We can have first we will decide the permutation of n.
males and another permutation of n females. Okay, and then we will crisscross them for the total permutations. Now we are actually filling the alternate positions first to get the answer.
Into n factorial into two position. One case men started, second case women started. The two cases are there. That will be 2 into n factorial squared. 17th question. How many ways are there? Five letter can be selected from English. Since we have to just select, we have to not put them together. That means we have to just find the combination, not the permutations. So we'll take 26C5. 26 total options. 5 we have to select. That will be 26 combination of 5. Bringing it down, 26 into 25 into 24 into 23 into 22, and 21 factorial can be reduced like from n minus r factorial, that is 21 factorial. We are cutting it off, leaving us with 5 factorial in the denominator. 1 I am not writing anymore. So we will cut off first of all this 11, then 8, 4 we can, I guess, yeah, 2, 5. This term is 10, this is 11, 26 into 23, that is 26 into 23, 60, no, 8, 18, 6, 12, 19, 598, 598 into 11 into 10 into 11 is 5980 plus 598, that is 8, 7, 5, 6, that is answer. Moving on to the next question. Find the expansion of x plus y to the power 6. For this concept, what we do is this is a general expression for this equation. If you have to expand a and b will be the constant ax plus by to the power, let's say n. The expansion will be n c. I'm writing a general term from I equal to 0 to I equal to n, sum of. So this equation is equal to, first term will be nc0 into ax to the power n and by to the power 0. So if you can, okay, plus nc1 ax n minus 1 into by. Now if you can see clearly, this 0 is put here, this one is put in the second part of the binomial expression, and this one is uh, n minus 1, n minus 0. So on. We are doing n c minus 2 ax n minus 2 by square. This is general term. We will expand it. For this question, it is 6c0 x to the power 6 plus 6c1 x to the power 5 y plus 6c2 x to the power 4 y squared plus 6c3 x to the power 3 y to the power 3 continued. I have the answer for this. It will be x to the power 6 plus 6 x to the power 5y plus 15 x to the power 4 y square plus 20 x cube y cube plus 15 x square y square. These terms will repeat now in the reverse order. What is the power 4 plus 6 x y to the power 5 plus y cube r 6. Find the coefficient of x to using the same thing. Since the power of y is 8, and we saw that whatever we write here, this is the power of the second term. Second term. That means we need r to be 8. So hence 8. N is 13. 13 C8, and the coefficients will be x to the power 13 minus 8 and y to the power 8. That will be equal to 13C8. Solve it, and x to the power 5, y to the power 8, just as we are. Let's solve once. So it's 13, 12, 11, 10, 9. This will be cut off by 8 factorial upon 5 factorial. 5, 4, 3, 2. This is 6. This is 3. This is not 39 into 11 into 3. That is 33 into 39. A plus b, a minus b. That will be 72 to 36 square minus 3 square. Yeah. 36 square, 1296 minus 9. That is 1285 is the answer. I'm pretty sure this is not the answer. I have messed up somewhere, but this will be the answer. What is the coefficient of x to the power 9 into the same question? I'm doing it again. The power of second part, x is the second portion of the binomial expression. So we'll put 19c9, 2 to the power, their difference, and minus x to the power, the 9. Solving it, 19c9 we have to evaluate. We have to keep in mind you have to include the expression with the minus, because whatever we wrote earlier, that is for the plus. If it is negative, you have to include negative. If the power is positive, the term will become positive. If the power is negative, the term will become negative. This was the part one. Thank you.